In this video, I am going to go deep dive into why do we log certain physical quantities when doing our data analysis in paper 5. But I'm going to start with the very beginning because I find that sometimes there's a lot of confusion about what log is and why do we log and how do we log. Okay, so after I talk about log, okay, I'm going to go through a list of the useful identities that you will normally encounter that is enough for you to solve paper 4 and paper 5 A2 questions. Not enough for you to do maths. Maths will need a little bit more different type of skill set. Okay, so we're going to just have the basic ones. Okay, we're going to do why do we log. We're going to talk about why is it a useful tool, and we're also going to talk about, this is pretty famous, people want to know, how do we handle when there's prefix in log. Okay, and also we're going to do a walkthrough of Feb March 19 paper 5.2 question 2. So when I reach this point, I will tell you, maybe you can pause the video. All right, you can pause the video so that you can try the question, then you come back again, then we can walk it through together. All right. Okay, so let's start from the top. What is log? Okay, so generally when log presents itself in maths, okay, you will see something like log, then there's A here, there's B here. Okay, so what is A? This A is our base, log base A. I'm going to write here for you. A is known as our base, okay, and B is known as our number. All right, and they actually represent pretty different stuff. Okay, this B here is number, and this number can be anything. So normally what we will write is the base is the same, and then the number is whatever that we want to substitute. Okay, so if you have log AB like this, okay, in physics, right, example of base is when A is equal to, say, very common, 10, log base 10, okay? Or A can be equal to the natural log E, okay? So if you press your calculator, which I will pull up right now, all right, this is my calculator. So if you want to find E, right, in your calculator, you see this red color part, this one, the E is here. All right, so I'll press shift exponent and alpha E. So you see this E here. Okay, so this is one place to find your E, which is around 2.72. Okay, or you could look at this exponent here on top of ln, right? So you see this E. So what I can do is I can shift E and then to the power of 1, which will give me the same answer, 2.72. All right. So whenever I write all this, it just means that I have different base. Okay. And this different base will plot us a slightly different graph. Okay. So I'm going to just write it out here for you in case this is for those who really need a bit of maths tutorial. Okay. But if you understand this, that's great. So the first case, if A is equal to 10, okay, normally what we will do is, of course, the long form method is to write log 10. Okay, let's say I find 8 lah. Okay, log 10, 8. Okay, so but normally in short form, we will write this as LG8. Okay, so you will seldom see this as log 10, 8. You will see this as LG8. Now, if I pop out my calculator, and in order to press log 10, I'll just need to log. This is log base 10 already, and I will put 8 here, which is around 0.90. Okay, so I'm going to put this one as 0.90. So this base 10, I will replace with different numbers ranging from 1 to 2 to 3 to 4, all the way to 8. And if I do so, this is the graph that I will get. This is the graph that I will get. Okay, so this is a basic log 10x graph. Okay, so if I'll zoom in, I'll show you the function log 10x, where we go from 0. There's no log 0. Log 0 is infinity. Okay, undefined. And all the way to all of this. This is x, log 10x. Okay, so from here, you can see that I have different values. And if let's say I want to find log 8, this is, I didn't crop properly, but this is the x-axis. This is x. Not sure. There we go. This is x-axis. So if I want to find when my number b is 8, so I go to 8. I mean, it's not, you can't read it, but I guess it is somewhat believable that this coordinate here is something along the lines of 8, 0.9 ish. So that is 8, this is 0.9. Okay, so this is what I mean by number. Okay, I substitute 8 as the number, but 10 is the base. When you press your calculator, you will use this button. So in physics, we use log base 10. And another useful one that we use, and it's normally only these two, it's highly unlikely they will use other base, because why? There's a little utility in other bases. All right. So in this case, I will write this one as log E8. Okay. And this log is 2.7, by the way. This value of E is 2.7. But we don't write this also. We prefer to write this as ln, the natural log of 8. Okay. And if I press my calculator, I'll find that my ln is right beside my log. So I'll ln here, and this one will be 8. So when I ln 8, I will get 2.079, I guess 2.1. I'll just write to 2SF because my graph can only provide to 2SF lah, the scale. All right, let me show you the graph for ln x. Right, so you will see this is a graph of ln x. What I did was I just adjust the A lah. So this A is 2.7, which is ln. Okay, and then you will get this graph. Well, Miss, the shape look very similar. Ah, yeah, correct. It's log graph, it's the same shape. It will just have different numbers, okay? So if let's say I look at log base 10, okay, when your A is equal to 10, this value here will be LG 8, this point. If I go to this graph and I look at 8, obviously the number is different because the value is different because the base is different, okay? So if I extrapolate this part here, I think it kind of looks like 2.1. This coordinate here, it is 8, 2.1. Okay, so if we check in with our value, it's about 2.1. All right, so this value here is ln 8. So whenever you log or ln something, it's giving a number a certain treatment, okay? But this treatment is contained between this idea, okay? So to know more about what is base and what is number, that one I will need to probably teach you maths or indices index. Okay, so we will stay away from that. All right, so what you need to know now is whenever we write this format, this LG here is log base 10. Okay, whenever we write ln here is log base E. And you should know where to find on your calculator. For physics, okay, for maths, different skill set, different video. Check out other channels. All right, so we're going to move on to the second part now. So hopefully you understand what is log, base, and number, and how it's commonly being applied in physics. Okay, so the second part is we're going to go through some useful identity in log. If you know these identities, then skip ahead. Skip ahead. Okay, it's only for those who need a bit of maths boost. Okay, number 1. This applies for any kind of log lah. So can apply for LG, can apply for LN. Okay, LNX, LGX. Or any base, it will work. Okay, as long as the base is the same. So in physics, all our bases are the same. Okay, so for here, the first one, you could say that, let's say I use log lah. So log A times B, bracket like that, is equal to log A plus log B. However, I'm going to write this in big red. Log A plus B, okay, is not equal to log A I don't know lah. Some weird things I see sometimes. This is not the same. Not the same. They are not. It's not the two-way street. Okay. All right. So when you separate them, okay, when two things are multiplied and you log it, you can split out the multiples. Okay, but this and this is not equal. All right. You can try and press your calculator and see lah. Put two numbers for A and B and see whether they are the same or not. Okay. Number 2. Let's say I have log A over B. Divide off. Okay. This will be log A minus log B. Because we are dealing with indices. So B is power -1. So plus -1. All right. So of course, in the same vein here, then please make sure you know that log A minus B is not equal to log A over B. I also don't know what is going on here. No, right? Number 3. Let's say you have log A to the power of n. Power 2, power 3, power 10, doesn't matter. Okay, you can bring down the n. So this is n log A. You know why not? Because it is log A times A times A ma. Let's say log power 3. So this is log A plus log A plus log A, which is 3 log A. Right? This is log A power 3. Get it? Okay. So A power 3 is A times A times A. And if we use this identity, okay, and we combine together, you will get 3 log A. Because it's log A plus log A plus log A. Because it's A times A times A. Because it's A power 3. That's why the 3 can shortcut and just bring down. Take this 3 and bring it down in front. And you get this 3 log A. Okay. I'm going to just let's put this aside as example. Okay, let's continue to the 4th identity. 4th useful identity for physics. For other maths one, you do that one on your own. The 4th one is, let's say I have log A, the base A, the number is also A. This one is 1. Yeah, 1. 1. For example, if you have log 10 is 1 because the base is 1. Ln E is also 1. My second favorite number after 0. Can always test. So maybe I put log 10. Okay, and I get 1. Right? And if I put ln E, E. Not 2.7 lah. That one is the S. That one is a rounded number. I get 1 also. Okay. Right. So other things about log, in case you mess up. I think I'll just write this in red. Okay. So other common mistakes, right, include. Let's say, for example, you have an equation that looks like this, because sometimes I see certain things, I don't know what is going on. So for example, if let's say you have, let's say, okay lah, let's think about A plus B power 4 is equal to C power 5. Okay, and then you log both sides. And then you write like that. This is wrong. Where is the mistake? Here. This part. Wrong. You put question mark. Wrong identity. How should you separate them? I mean, how should you log? Whenever you log something, right, you must log the whole thing first. So to avoid this kind of error, which by the way is this error, always log the equation in its entirety, right? So I don't care lah what your equation is. It can be A plus B power 4 is C power 5. You have to, you must, you should log both sides like that. Then only you see whether you got identity to use or not. You can maybe bring down the 5. You maybe can separate the A and B. But now in this case, cannot log. Okay, so it is log is not multiply, it's not divide. You can't log A and then log B, like you multiply a common factor. It's not the case. You are telling me that this, whatever A plus B power 4 is, this one is one number on the left, and C power 5 is another number on the right, and you log both sides together. Okay, so this is important, especially when you are linearizing equations that are a little bit more complicated than usual. Okay, so the recommendation is like this: log both sides. I write for you. When taking log and ln or ln, both sides, you will include the entire expression. So whatever the entire expression is, if it's A plus B power 4, then it's A plus B power 4. Okay, and I think these identities should be enough for most questions, if not all. Just want to include a final note here that when is your log 0? You go back to your graph. Your log is never 0. Not going to happen. Log is never 0. Okay? So if log is never 0, second problem here is log is also never negative. So your x cannot be, sorry, not log is never negative. Log can never, the number can never be negative. Okay, anyway, let me write this down. Create some space, I'll write it down. Number 1. Whenever you have log, the number is A, or ln A must be greater than 0. Okay, you see here, this is an asymptote, so there's no values of x. The domain should start from 0 to infinity, not including 0. Okay. Number 2, if A is greater than 1, is it 1? Now 1 here, 1 here. So if A or x is greater than 1, okay, your log A is greater than 0, positive. So this means if A is less than 1, your log A is less than 0, which is negative. And if A is equal to 1, log A is equal to 0. Let's try. Ta-da! Log 1, 0. Ln 1, 0. Okay? So these are certain properties about log. Your domain must be greater than 0. Okay? And 1 is a crucial point. If you are greater than 1, if whatever that is inside here is greater than 1, whether it's log or ln, then the value of log A must be positive. If it's less than 1, then the value of your log A will be negative. If it's equal to 1, then the value of your log A is 0. Okay, so hopefully this will give you a better sense of what log is. It has certain points which are the same, whether it's log or ln, or basically it's not dependent on the base. Okay, the base will only affect the scale of the graph, but if I zoom out and let you look at it, the graph is pretty much the same shape. Okay, and these identities are useful when you linearize things, or if you need to simplify an equation. Doesn't matter whether it's question 2 or question 1